Alright, let's start integration by parts. And the way integration by parts works is essentially using this formula here to look at situations where you have a product of two functions, where both of them are functions of x. Okay? And that's the integration by parts rule. I would always recommend you write down u, write down u prime, write down v, and write down v prime. Make yourself a little 2x2 table, okay? Because it does get tricky. You put some limits in there, and it does get a bit messy, and it's very easy to make a little mistake. Let's look at an example. So say I had to find the integral of x cos x. Now, we've got to decide which one of these is going to be u. And generally speaking, the way you decide it is which one do I differentiate, which one becomes easier to deal with once it's differentiated. Now, cos x, you differentiate, you get sin x. Yeah, minus sin x. Whereas the x, when you differentiate it, you get 1. And so, it's just become easier. I just deal with a constant now. And so what I'm going to do is say let u equal x, and therefore v prime is going to be cos x. And if u equals x, then u prime is 1. If v prime is cos x, then when we integrate this, we get sin x. Now, you can make either one. You can still do them. You can still do the integral, but you choose which one will make your life easier.
No, I mean v is minus sin x.
Sorry?
V minus sin x. So it's minus sin x.
Minus sin x.
No, because if you differentiate sine, you get cos.
Also, you know your equation. But Jordan, why are you saying it like that?
What?
Your equation is x cos x. Your v is sin x.
No, alright, so let me start again. Alright, I'm getting a bit confused. Too many people talking. Right, the first thing is, here, u is x and v prime is cos x. Right, that's the first thing. The second thing is, when you differentiate sine, you get cos x. So when you integrate cos x, you get sin x. If I differentiate cos x, then I get minus sin x. But I'm not differentiating it, I'm integrating it. Do you see how those small little things can lead to errors, and how easy it is to slip one little minus sign, it changes your answer, and you lose the accuracy mark. And you will lose the method mark if you don't show the examiner what you're doing. And it comes by labeling what you're doing. So I'll put down u v prime dx equals uv take away v u prime dx. And so then I'd simply do my substitution. U times v is x sine x. Take away the integral of v sine x u prime is just simply 1. And therefore, we can say x sine x take away the integral of sine x is minus cos x plus c. Why? Because if you differentiate minus cos x, you get sine x. If you differentiate cos x, you get minus sine x. Let's just write that up. So x sine x plus cos x plus the c. Don't forget that constant of integration, okay, which is 1 mark. Because there's no limits. Right. Do you understand how that works? And more importantly, do you understand how easy it is just to make that odd mistake? Okay, it's very easy to do it. Getting the integral mixed up with the differential, getting the minus sign incorrect. So the moment you see your trig, a cos or a sine, you've got to think about what's going on here. And the best way to do it is lay your work out clearly and take your time. Don't rush through it. Okay, let's do another one. This time let's integrate x ln x dx. Hands up if you want to have a go at doing this. Okay, alright. I'll give you a minute, have a go, and then we'll go for it. Okay, so in order to integrate something like this, if we go back to the formula for integration by parts, you know what you've essentially got is u v prime dx equals uv take away v u prime dx. And what we basically want to do is match up the x and ln x with u and v prime. And we know we can both integrate and differentiate x, but for the moment with the ln x, it's easier for us just to differentiate it. So we want to pick something that we have to differentiate. Now from this formula, the thing that we differentiate is the u part. So if I say u is ln x, and therefore x is v prime, and just write that out like this. I'll show you in a second. Yeah. Right, so u equals ln x, and therefore u prime is simply 1 over x. V prime is x, and therefore v equals x squared over 2. And now if I just call this I, just to say here's my integral, so I therefore equals u times v, so it will be x squared over 2 ln x, take away the integral of v, which is x squared over 2 times u prime, which is 1 over x dx. You can obviously take the half outside. Okay, so that becomes x squared over 2 ln x, take away simply the integral of a half times x squared over x gives us x, so that becomes x squared divided by 2 plus c. And we can tie that up. We've got x squared over 2 ln x minus a quarter x squared plus c. But it all comes down by thinking about which one can we differentiate, or which one becomes easier if we differentiate. Okay? Right, any questions before we move on? Yes? Yes? Alright, yeah, we're going to do that now. Example. Yeah.
Can you do it by making u, x and v prime?
Right, that means you'll have to integrate ln x.
Yeah, that's what we want.
And yeah, that's example 4. Example 3. We're doing that now. Okay. But in either case, say for argument's sake, you know that the integral of ln x is x ln x take away x. Okay. Personally, I think it's just easier just to write the differential of ln x as 1 over x. And there's more chances you're actually going to cancel out, as we've done here. Okay, the u prime over here, okay, the 1 over x ends up cancelling with the x squared over 2. So it just makes life a bit easier, as opposed to writing x. You've got another ln x to deal with. Okay, so you've got to be careful. You've got to think about what is it that makes my life easier. Now, the integral, to do the integral of ln x, we do a little trick, and we say, well, this is, to integrate ln x is the same as doing 1 times ln x. Yeah, just give me a second. Okay. And so again, if we go to u v prime, so if you go to u v prime take dx equals uv take away v u prime dx, then we can match this up. Now we know that if that's ln x, then u prime is simply 1 over x. V prime is 1, so if we integrate that, v just simply equals x. Now we can substitute this back in, so you've got u times v, that gives us x ln x, take away the integral of v x u prime, which is 1 over x dx. And that simply gives us x ln x, take away x plus c. Right, so let's look at what happens if we've got limits now, and we've got b and a. All we do is integrate uv prime, and use limits in our integration. So say we had something like this, where we've got pi over 6, x sine 2x. Okay. Let's start by writing out our rule. So uv prime dx equals uv, take away v u prime dx. And let's just over here establish what is what. And if we let our u be x, then u prime is simply 1. V prime, if that's sine 2x, then integrating this, v will give us cos 2x divided by 2, and with a minus as well. Let's now substitute this back in. So you've got a u u times v, so you've got a minus x over 2 cos 2x with our limits of pi over 6 and 0. And then we also have the integral of v u prime, so v is going to be a minus a half again, and so we can basically make that positive and put the half outside, and that gives us cos 2x times u prime, which is simply 1. Okay, and if we were to tidy that up, the integral of cos 2x will give us sine 2x over 4. So sine 2x divided by 2, so you get a quarter there. And don't forget the limits. Let's put pi over 6 and 0, so that will be pi over 6 and 0. And this part here, we know the cos of 0 times 0, well, that would just give us 0. So we've essentially got minus a half times pi over 6 times cos 2 pi over 6, which is simply pi over 3, and then plus that second part. If we then substitute again, the sine of 0 would just give us in radians, yeah. Right. So we know the sine of 0 is simply 0, so that gives us minus pi over minus a half pi over 6 cos. Now the cos pi over 3, let's substitute that in. We know the cos pi over 3 is simply equal to a half plus 1 over 4 sine 2 pi over 6 is simply sine pi by 3. Okay, we could put in take away 4 sine 0, which we know is just 0. Sine pi over 3 is square root of 3 over 2, so that gives us square root of 3 over 8, plus 6 times 2, so that gives us 24, with a minus sign, and then we can tidy that up to give us 3 root 3 minus pi divided by 24.